Hi guys, this is Mrs. Homer, and today we're going to be looking at how minerals are formed. So you're going to want to be filling in your notes as I go through this presentation. And so this is our minerals packet. It actually starts with elements, compounds, and mixtures, and we're going to be filling in kind of the last two pages, not the very back page, which is our vocabulary list. So if you want to flip there, at the very top, you're going to see mineral formation, and that's where we need to be. So go ahead and pause the video until you find that page. So I want to start just by pointing out what a geode is. A geode is a rounded, hollow rock that is often lined with mineral crystals. And these are really cool. You've probably seen one before. I have plenty on my shelf. You can actually buy these and crack these open. We can make these by hand because we can poke holes in these round rocks and fill them with crystals. But you can find these in nature as well. And these kind of show one of the ways that minerals can be formed, and that's through crystallization. And so what is crystallization? Crystallization is the process by which atoms are arranged to form a material that has a crystal structure. That repeating pattern is that crystal structure. And so all minerals have to crystallize. That is one of the definitions, one of the parts of the definition of a mineral is that it has to have a crystal structure, so it has to crystallize. So we're going to take a look at how minerals how they can form, which means how they can crystallize. So they can do that in one of three ways. Number one, when lava or magma cools. Number two, they can crystallize when materials are dissolved in water. And number three, they can crystallize through organic processes. Excuse me. So we're going to start with lava and magma. So first of all, there is a difference between magma and lava. Magma is what we call it when it's inside of the earth. Lava is what we call it when it's on the earth. And so when you have minerals can be formed either with magma inside of the earth's crust or lava on the surface. And the rate or the size of the crystals, and this is kind of the cool part, the size of the crystals is really going to depend on the rate at which the magma or the lava cools and the chemical composition, what that lava or magma is made up of. And so the first one is magma. Magma inside of the earth is going to cool very slowly, and this is going to lead to really big, larger crystals. You're going to see quartz, feldspar, tourmaline, and mica. These all form through magma. So this is where we get really big pieces of quartz because this magma is cooling very, very slowly. However, on the flip side, when magma erupts, it becomes lava, and that's going to cool really quick, and that forms very small crystals. So leucine and olivine, they're minerals that form in lava, and they form very small crystals. Now, both magma and lava are rich in silicon. So minerals that contain silicon are called silicates, and they make up the majority of the Earth's crust, which makes sense because magma and lava are both part of the Earth's crust. And so, again, those are called silicates. Just take a second, make sure you have all your blanks filled in. Those are the pink words. You can always go back in the video if you need to. All right, so the first way that we can form is when magma and lava cool and we get crystallization that occurs. The second way we can have is minerals from solution. So sometimes elements and compounds can be dissolved in waters to form solution. So again, a solution is just when something is dissolved in something else. And when we have the element or the compound that leaves the solution, we can get crystallization occurring. So the first way this can happen is through evaporation. And so when water evaporates, we can get mineralization, we can get crystallization occurring. And so you're going to see that when we did the salt and the Epsom handprints last week, we're going to see that occur because we'll see the crystallization as a result of that. You'll also see halite, gypsum, and calcite. They all form that way through the evaporation of seas or oceans. You get to see that mineral formation through evaporation. Now, another way that minerals can form from solutions is through that hot water solution. So when you're really deep underground, water gets heated to a very high temperature because of that very hot magma. And that hot water can dissolve more minerals, and as they cool, the crystals are formed. So quartz, silver, and gold are deposited that way. Now the cool thing about these deep underground hot water pockets is that they actually burrow their way through the rock. And when they do that, they make these tiny little veins kind of through all the little cracks in the rock. And so that is where we find those thin streaks of gold and silver and quartz. And a vein is just a narrow channel of minerals that is different from the surrounding rock. And so the water kind of breaks through and busts and fills those areas and those pockets. And when we mine for those minerals, we're looking for those veins of gold or those veins of silver. All right, so first we can get through magma or lava cooling. Second, we can get it through solution, through evaporation or hot water. And lastly, some are actually formed organically. Now, part of the definition is that minerals must form through inorganic processes. But sometimes they can also, and that's a big also, they can also form through organic processes. For instance, clams produce shells, and that's made out of the mineral calcite. So you can have some that additionally get formed through organic processes. So 3 ways: magma, lava, through solution, or organically. Now, where are we going to find these minerals? You're going to find them mainly in the Earth's crust, because that's where all those minerals are formed, because there's formed into different types of rock through the rock cycle. And you're going to find them inside of what we call an ore. An ore is a deposit of valuable minerals contained inside of a rock. A rock is just a mixture of minerals. So we pick up that rock, we separate that rock into different ores, and so we get our minerals out of that. And so we don't usually typically find just a big clump of lead or a big clump of iron. We find a rock that contains it, and we have to pull those minerals out. And that's what the ore is a deposit of valuable minerals contained in a rock. So the last thing I want you to do is to go back through your notes that we just went over and look for the examples of the minerals formed in these 4 different ways, and go ahead and write in the examples on your notes, and we'll get over those when I come back. Have a great day, guys, and I'll see you soon.